KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, actually in last class we discussed, right, 3 example problems related to static friction and kinetic friction, right? So in this class we are going to discuss another type of friction. I already told you friction is of 3 types: static friction, kinetic friction and rolling friction. Okay, so here we are going to discuss about rolling friction, right? Okay, so when a body rolls on another surface, just like a wheel, right? So the importance of wheel in our human's life is very great, okay, because of that wheel it led to the development of a vehicle, right, etc., right? So what I am saying is, when one surface rolls on another surface, I am not saying when one surface is moving on another surface, I am not saying when one surface is at rest on another surface. It is very clear, I am saying that when one surface rolls on another surface, right? So there we have to discuss this type of friction, that is rolling friction. Okay, right. So you observe carefully, and I will explain you sentence by sentence. You just focus. Generally, when a body rolls on a surface, only one point is in contact. Only one point is in contact, and this point has no relative motion. So we feel that no friction, right? So please be concentrate here. When a body rolls on a surface, only one point is in contact, and this point has no relative motion. This point has no relative motion. This point may have motion but may not having relative motion. That is very important. This point has no relative motion. So we feel that no friction, because what is friction? Force which opposes the relative motion between the two surfaces which are in contact with each other. So here what I am saying, the point which has no relative motion, right? So that is the reason here we can say that no friction. Okay, right. But in practical this will not happen. So what will not happen? We are saying here no friction, but in practical there is a friction. That only we are going to see. But in practical this will not happen, and friction, that is rolling friction, exists. Okay, that is rolling friction exists. So try to understand why we added the word rolling. So already we discussed static friction, already we discussed the kinetic friction, and now we are in a discussion about rolling friction. So rolling, the word rolling is talking about the state in which both the surface were in. Okay, so the rolling friction exists here. For the same weight, rolling friction is much smaller than static or sliding friction. So in this sentence he is talking about magnitudes, difference in magnitude of static friction, kinetic friction and rolling friction. So you can say that rolling friction is less than kinetic friction is also less than static friction, that you can say. That is the statement which is talking about the magnitude difference between static friction, kinetic friction and rolling friction. Okay, right. Next, this is the reason discovery of wheel. This is the reason discovery of wheel has been a major milestone in human history, right? I hope you understood why the discovery of wheel has been a major milestone in human history, right? Because see the magnitude difference between three types of friction: kinetic friction, static friction and rolling friction, right? So friction has both advantages and disadvantages, as I told in previous class, right? What is the advantage means, for the comfortable walking of human, friction is required, but at the same time, if you go for industry, the wearing and tearing of machinery parts took place because of friction, right? So that is the disadvantage, because the matter is going to loss. The material is going to loss because of friction. But anyhow, when compared to the static friction, when compared to the kinetic friction, here the magnitude of rolling friction is very less, so that the opposing force is less, so that the power loss is minimum. The power loss is minimum. That is the advantage because of discovery of wheel. Okay, right. Next, during rolling, the surfaces in contact. During rolling, the surfaces in contact get momentarily deformed a little. During the rolling, the surfaces in contact get momentarily deformed a little, and this results in a finite area of the body. This results in a finite area of the body, right? So he is explaining the situation when one body is in contact with another surface. Okay, so when one body is in contact with the surface, right, so there it gets momentarily deformed a little, and this results in a finite area of the body. Okay, being in contact with the surface, it results in a finite area of the body being in contact with the surface. Okay, right. The net effect is that the component of the contact force, the resultant effect is that the component of the contact force parallel to the surface opposes motion. The component of the contact force parallel to the surface opposes the motion. That only we are calling it as friction. But here, because of the situation, it is termed as rolling friction. Okay, right. In many situations, friction has a negative role. Okay, in the bracket, dissipates power in the form of heat. So that I already told you in case of industries, right? So the wearing and tearing of machinery parts took place because of friction. Okay, so what is the negative role means? This is the negative role. By using, so that you can overcome by using lubricants and ball bearings. That you can overcome, so that loss you can minimize. By using lubricants and ball bearings to reduce friction. Okay, so in many situations, friction has a negative role, thereby using lubricants and ball bearings you can use to reduce friction. Next, due to the less surface area in contact, in case of rolling friction, power dissipation is less. Due to the less surface area in contact, I already told you when I was explaining the concept of friction, the reason for friction is basically the irregularities of surface molecules. If you go in deep, again the electrical forces, right, and the forces between the primary particles come into the picture, but basically the surface irregularities are the reason for arising the friction, for arising the frictional force. Okay, right. Due to the less surface area in contact, in case of a rolling friction, the power dissipation is less. However, kinetic friction dissipates power, but important to stop relative motion. It is important to stop relative motion. Okay, that is right. Okay, So it is kinetic friction dissipates power, but it is important to stop relative motion, because while braking, you know very well, bike brake and bus brake and car brake, so there we need friction, right? So when we are going to brake means before that situation the vehicle is in motion, right? So to stop the vehicle we need to press the brake, so we need to reduce the speed of the vehicle. So there kinetic friction is the matter to discuss, but kinetic friction dissipates power, but it is important to stop relative motion. Okay, right. Friction is also important for our daily life. Friction is also important for our daily life to walk, and for vehicles regarding smooth running to accelerate the vehicle also, right? Once if you take the car onto the road, so the car has to accelerate, no? So you are going to increase the speed of the car. If the speed is increasing with respect to time, if the velocity is increasing with respect to time, means the vehicle is said to be accelerating, right? So either to accelerate of the vehicle or smooth running of the vehicle also, friction is important. How I explained, the friction requirement is needed in case of comfortable walking of a human. Similarly, for the smooth or comfortable running of a vehicle, friction is the primary requirement. At the same time, even to accelerate the vehicle also we need friction. Okay, so this is all about rolling friction. From starting of this class up to here, it is all about rolling friction. Okay, right. Now we are going to discuss the next continuation topic, circular motion. Next continuation topic, circular motion. Okay, right. So listen carefully. So in the last chapter, that is motion in a plane, also we discussed about circular motion, but here also we are going to discuss about circular motion. What is the difference means, in this class circular motion we are going to discuss the circular motion in terms of friction. So what is the role of friction when a body is moving along the circumference of a circle? You know very well, when we are moving along a road, even though it is horizontal, at some times we have to cross, we will get some turnings, right? So when the body is taking a turn, it is like arc of the circle. The turning of a road, the turning of the road is like arc of the circle. So when the vehicle is overcoming arc of the circle, when a vehicle is going to overturn or overcoming the arc of the circle, at that instant of time the vehicle is in circular motion. At that instant of time, what is the role of friction? That is our discussion. Okay, right. See this. We know that acceleration of a body moving in a circle of radius capital R. We know that acceleration of a body moving in a circle of radius capital R with uniform speed v. With uniform speed v is v square by r. And the direction of this acceleration is directed towards the center. So already we know the circular motion, So when a body is moving along the circumference of a circle, then it is said to be in circular motion primarily or basically. Then if you go for characteristics or detailed explanation of circular motion, when a body is in circular motion, first centripetal force is acting on it. Centripetal force is acting on it. Afterwards, depends upon the frame of reference, centrifugal force also will come into action. So two forces are acting on the same body which is in circular motion, right? So here he is talking about first centripetal acceleration, right? So that is acceleration of a body moving in a circle of radius capital R with the uniform speed v is v square by r, directed towards the center. Okay, right. According to the second law, Fc is equal to mv square by r. According to the Newton's second law, Fc is equal to mv square by r, right? So it is the centripetal force. Fc is equal to mv square by R, right. For a stone rotated in a circle, centripetal force, right, here force ma. So centripetal force is provided by tensional force in the string. So here centripetal force is provided by the tensional force in the string in case of rotating stone. Okay, right. Next, the centripetal force for motion of a planet around the sun is the gravitational force on the planet due to the sun. So in case of rotation of earth, so it is also circular motion, no, right? So in case of rotation of earth, who will provide the centripetal force? Means gravitational force. Try to grasp the difference. In case of rotating stone with the help of string, here tensional force is providing centripetal force, but in case of motion of a planet around the sun, gravitational force is balancing centripetal force, or gravitational force is providing centripetal force. Okay, right. Next, for a car taking a circular turn, so this is the daily life situation. So this is the important topic for us in this topic, in this class. Okay, for a car taking a circular turn on a horizontal road, the centripetal force is the force of friction. Right? So you observe carefully, three examples are given here. These three examples are talking about circular motion in different situations. In first case, it is about rotating stone. In second case, it is about rotating a planet. In third case, it is about the rotating or turning of a car. Okay. In case of rotating stone, tensional force is providing centripetal force. In case of motion of a planet, gravitational force is providing centripetal force. In case of rotating car, frictional force is providing centripetal force. Okay, right. Now we are going to discuss first motion of a car on level road, right? Actually our discussion is motion of a car on curved road like this, because it is a circular motion. Okay, but before going to discuss the motion of a car on curved road, first we need to discuss motion of a car on level road. So horizontal road like this, see the light ma, so like this, right? So horizontal road, curved road means it will be like this, horizontal road means it will be like this, right? So motion of a car on a level road, see here the forces acting on the car. So when a car is in motion on a level road, what are the forces acting on the car? One is the weight of the car, another one is normal reaction, third one is frictional force, right? So one is the weight of the car, another one is normal reaction, another one is frictional force, right? So three forces are acting. I will repeat once again. One is the weight of the car, another one is normal reaction, and another one is frictional force. So what is weight, what is normal reaction, what is frictional force? We are in a discussion continuously, right? So what is the weight of the car? Because of having certain amount of mass, the earth is going to pull that mass towards its center, right? So that is the weight of the car. It is mg. Okay. Next, the second one is normal reaction, right? So the normal reaction means it will act upward direction. Which balances the weight when the car is in the state of rest, or when the car is moving on a horizontal road, otherwise level road. Okay, so that is important. When the car is moving on inclined plane, that will be different situation. There n will become equal to mg cos theta, that we have seen in the last class when we solved a second problem, that is the motion of a block on a inclined plane. Okay, but here the topic is level road, so that the normal force is going to balance the weight directly. Okay, at the same time, when the car is moving towards what is that right direction, the frictional force is acting in some other direction. Some other direction means opposite to the direction. Okay, so this picture is indicating the motion of the car on a level road. Okay, right. So now we are going to discuss the consequences when the car is in motion on a level road. Okay, see here, as there is no acceleration in the vertical direction, right? So vertical direction means like this, so in this direction there is no acceleration. The car is moving either like this or the car can also move like this. Okay, so moreover it is a horizontal level road, no, right? That is the reason. Okay, so as there is no acceleration in the vertical direction, you can write n minus mg is equal to 0. N minus mg is equal to 0. When n minus mg is equal to 0, n is equal to mg, right? So mathematically, when n minus mg is equal to 0, you can write n is equal to mg. Okay, here centripetal force provided by the component of contact force. Here centripetal force provided by the component of contact force between the road and the car tires. Centripetal force provided by the component of contact force between the road and the car tires. Here, I will repeat once again, this is important point because he is giving the reason, he is giving the explanation about the centripetal force, how it will be provided. See this, the centripetal force provided by the component of contact force between the road and car tires. So what is the contact force between the road and car tires? It is the frictional force. It is the frictional force, right? So here centripetal force is provided by the frictional force. I already told you here 3 examples, right? So in case of last example, when a car is moving on a horizontal road, right, centripetal force is required, the centripetal force is provided by the force of friction. But our discussion is horizontal level road only. If you go for inclined plane, if you go for curved road, then you will get it clearly. Next, it is the static friction provides the centripetal acceleration. It is the static friction provides the centripetal acceleration. Okay, it is the static friction provides the centripetal acceleration. Next, static friction opposes the impending motion of the car moving away from the circle. Static friction opposes the impending motion of the car moving away from the circle. Okay, so here itself we can write F is less than or equal to mu s into n. So F may be equal or less than or equal to mu s into n, that is equal to mv square by r. F is less than or equal to mu s into n, that is equal to mv square by r. Okay, so v square is less than or equal to mu s into r n by m. So mathematically, so you take this r to this side, then what will happen? Mu s into r into n, right? So take this mass to this side, then what will happen? Mu s r n by m. Mu s r n by m. So this is what v square, right? This is what v square. Then you can write it as v square is less than or equal to mu s into r n by small m. That is equal to, because n is equal to mg, no? We know that n is equal to mg. In this situation, on a level road, when a car is moving on a level road, in this situation only n is equal to mg. Okay, so if you write in place of n, if you write mg, then what will happen? M will get cancelled, no? So then it is equal to mu s into rg, mu s into capital R small g. Okay, right. Next, which is independent of mass of the car. So what is the independent of mass of the car? Speed of the car. Speed of the car is independent of mass of the car. Speed of the car is independent of mass of the car. This is the important point we have to keep in mind, which helps us while solving the problems related to this topic. Next, this shows that for a given value of mu s and capital R, this shows that for a given value of mu s and r, mu s means coefficient of static friction, r means, right, here, right. So in case of mu s and r, this shows that for a given value of coefficient of static friction, coefficient of static friction and radius of the circular path, radius of the circular path, if it is, right. So here in this discussion he is comparing the motion on a horizontal road to the motion in a circle. So next topic is completely motion of a car on circular road. So that's why you try to grasp the difference, right. There is a maximum speed of circular motion of the car possible, namely V maximum is equal to square root of mu into Rg, square root of mu into Rg. So my sincere request is, from here to here, he is comparing the motion on horizontal road to the motion on a circular road, right. So our next continuation topic is motion of a car on a circular road. There I will repeat again this information and I will continue with the next continuing information. Okay.